Okay, well, I found something very interesting in my research in electromagnetic waves where you start out with Planck's constant, but it's not the regular SI exact definition where it approximates right here because if you actually do the calculations, like I made this Python tool that does the calculations for me by doing the formulas for me. So when I do very specifically a wavelength of 1 meter, I get the speed of light as frequency, and I get Planck's constant here as momentum. But as you notice that when you calculate 1 meter and you turn up the precision, it seems to not stop at 1.5. It seems to keep going. So with my tool I can actually increase the precision. So we can double it. And as you see, Planck's constant gets longer to the negative 68 power. So we can do this again, make it a little bit longer. Let's try 150. Okay, we're at 68 power here still. So notice the exponent's not changing. See, it's still to the negative 68 power. So I can give it as many decimal places as I want. So now we're at this point right here. So this is actually what I wanted, so it's a whole number. It doesn't stop at, doesn't say exponent whatever right here. So now, I've done all this with calculating just 1 meter. So now I'm going to take this number here, the momentum, I'm going to use that as a wavelength. But this is not Planck's constant, this is a different Planck. This is a Planck's constant that is twice as small. It's at the negative 68 zeros instead of 34. So this is doubled. Doubled and shrank in size. So then when we do this, we now get, so now look, the speed of light is now in energy for Planck's constant that is twice as small as normal. And look at this, we got momentum is just under 1 kilogram, just slightly under. And right here we have a mass of 33356. Now watch what happens when I take time period and use time period as a new wavelength. You know, we're considering now that Planck's constant is a locked-in wavelength with these characteristics in it. So we're going to take the locked-in time period for Planck's constant as a wavelength and use it as a wavelength. These are really, really small numbers, so we have to turn our precision up. So now we use that time period as a new wavelength, and now look what happens. Energy has turned into the speed of light squared. Momentum has now become the speed of light, and mass now has become 1 kilogram. And you see this right here? This is the noise that I'm getting because I did not put the entirety of Planck's constant into, you see, if I went back up here and I used more digits of this number, then this leftover garbage would not be here. Because this number right here ends right here. And this number is just slightly longer than this number. See that? But notice that they both end on similar numbers. So this is just regular decimal noise right here that can be eliminated. This is not rounding error. This is not floating error. This is just the reason that this is here. These numbers is because the number I used here is slightly shorter than these other numbers. They're short by about this much right here because there's a phase, there's a dimensional shift that happens in the math. When you take a time period of Planck's constant and use it as a wave, then there's a dimensional shift in the speed of light from momentum into joules. See, Planck's constant goes from the speed of light in joules to the speed of light squared in joules from this wave period and this wave period. So between this wave period and this wave period, you have the speed of light squared. So there's a transition between these two wave periods is the speed of light squared. And we need to have these locked in characteristics with energy and the speed of light and momentum and mass. And force also has a characteristic to doing this. And if you notice, this is the number right here that has to shift with these other numbers. Because look, mass over here, everything is shifting by one row. So you got one here, speed of light here, Planck's constant as momentum. So when you take Planck's constant and swap it with wavelength, then see, then momentum becomes 1 and wavelength becomes Planck's constant. Because here momentum is Planck's constant and wavelength is 1. So when you take Planck's constant and swap it with wavelength, you get 1 for momentum, and frequency becomes energy. And time period right here becomes mass. So here is where time period of the wave turns into mass. So at 1 meter, you have a momentum of Planck's constant, and you have a mass, see, of this number right here. When you take momentum and swap it with wavelength, then the time period for Planck's constant turns into mass. So every single piece of mass has a standing wave in it that is this right here. This is the standing wave of the building block of mass right here, because it represents 1 kilogram of momentum at the speed of light energy, and it also represents the locked in time standing wave period or 1 meter at a frequency of the speed of light. So the frequency of the speed of light at 1 meter has a superposition time period of the mass equivalent to Planck's constant as a standing wave. So Planck's constant, the minimum energy you could possibly have, which I believe you have to use the speed of light as your wavelength. Okay, so momentum becomes the standing wave. Here's where Planck's constant becomes energy, or when the wavelength at the speed of light gives an energy at Planck's constant, and the momentum is also this number right here. I believe this right here is another constant as well. This one right here is a little bit more important because it reveals the superposition of energy, momentum, and mass and force, I believe, all together as one. Yep, see? So now we're looking at this superpositioned wave now, which gives us the speed of light for mass. Force is equal to 1, pretty much, with a Newtonian gravity of the time period that was that 3335 number. So this 3335 number is the force in meters per second, the leftover force from momentum doing a dimensional shift from momentum to mass. During the dimensional shift from momentum to mass, when the speed of light hit the speed of light squared like this, force inherited that 1 kilogram of mass as its momentum. That's what gravity is. Like this number right here represents the tiny bit of leftover. That, see how these numbers, see how this is just under 1? This is just under 1 because, look, this much right here was taken from it. I believe that's what this is doing. Like this little bit of energy was taken, left over from the transition between speed of light squared to energy being squared by the speed of light again, mass becoming the speed of light, and force is the leftover from that transition that turned into gravity. So this is basically how time dimensional shifts happen, where these superpositioned time period waves got locked into standing waves of time, and another time dimension started again. So these are all like either starting positions or locked in super time wave positions, where these are not just standing superpositioned waves of light, but they're actual standing superposition waves of time as well, where this superposition wave from mass right here, the mass of a wave that's moving that has a size of the speed of light gives this as mass, and if you take this as a wavelength, then you get these characteristics. You get these locked numbers. The speed of light squared, and the squared speed of light times the speed of light again gives you this number. But then this number right here must be another superposition standing wave, right? Because that's what we're doing. We're just taking the time wave period and we're using it as a wavelength to see what kind of superposition it may impose, what it has built into it. So now we're taking this time period from this superposition and looking up its period of its superposition. And what do we get? See, now force has become the speed of light, almost. Mass has become the speed of light squared. Momentum has become the squared speed of light squared again. And this has been multiplied by the speed of light one more time to become this number. So each step you are multiplying the amount by the speed of light. This multiplied by the speed of light is this. This multiplied by the speed of light again is this. And this multiplied by the speed of light again equals this. So each dimensional shift you're multiplying by the speed of light. So then we do the same thing again. We take wavelength, time period, use it as a superposition wavelength, and see what this brings. See, look, it's another step. We have multiplied by the speed of light again. We have multiplied mass by the speed of light again. We've multiplied each one of these. Force, mass, momentum, and energy all get multiplied by the speed of light every single time I take the time period standing wave and I turn it into a wavelength and I check its characteristics. See? And look, it just did it again. See, these are all numbers that are multiplied again by the speed of light again and again and again. And that's the pattern of this superposition time period for reality, for matter, for energy, momentum, mass, and force. These are how, and time period, and I'm pretty sure temperature is probably connected in there too using Boltzmann's constant, and I'm sure radius probably in there too with frequency and angular velocity via the circumference and the speed of light and angular frequency. The angular frequency, angular velocity, radius, circumference, frequency, and wavelength are all connected and looped close to each other. And now it's like that energy, momentum, mass, and force are all connected to each other by time period. And temperature is connected to the rest of them by Boltzmann's constant. And that's how all these variables relate to each other. So you can keep doing this probably indefinitely, or you can keep going deeper and deeper and deeper into the numbers. So now look at the joules. This is just a ridiculous amount of energy, but that's the thing. You see, this is a very, very tiny wavelength, so this is giving a very large amount of power. This is basically showing us how we can step up our power output at precise levels. Like if we take this exact wavelength that I just put in here and we have a machine that can reproduce this exact wavelength, it'll give us this amount of energy in joules exactly. So this is actually giving us a roadmap of how we can increase our energy levels in lockstep with energy, mass, momentum, force, all in lockstep with each other, just by constantly using the standing wave time period. And just, if you want to get deeper and deeper energy, you just keep using it as the next wavelength. And each time you get deeper and deeper and deeper into the energy building blocks of the cosmos. And if you notice that some of these numbers eventually start to look like spectrum lines in the EM spectrum, where multiples of C are the harmonics of the speed of light stacking on each other as standing waves. So like a standing wave becomes a locked-in time period of a superposition bunch of waves. So a very tiny wave is a superposition of these characteristics that are all locked into place within that wave's characteristics. I mean, that may be hard to understand for some people, but this is what the math is telling me, that all these variables, force, mass, momentum, energy, are all connected in lockstep with each other by the speed of light squared. And every time you dive down into the next time period, and then the next and the next, you always see these characteristics all in sync, go lockstep together. So there you have it. There's the discovery on light wave mechanics, something that Albert Einstein and Max Planck and probably Bohr and all those great scientists of the past were all searching for. But because they didn't have PowerShell or Python to help them with the math, they all had to do all this longhand. Can you imagine trying to do all these big numbers longhand on paper? Doing math. I mean, this is all simple math, straightforward math, but these numbers are enormous. It would take forever to try to work all these out by hand. So the fact that I just can, I can just take this and copy it and just bring up my line from before, delete my previous entry, like a few button presses, paste in this line as my new input, then just do it again. You see, I just did probably hours worth of longhand calculations just in milliseconds right there. And that's the difference between what Max Planck and Einstein and even Maxwell. Maxwell, I don't know how he was able to do what he did with just by candlelight feather for writing with. That is incredible. But this is what I was able to do with the work that they did with a computer. And this is what the results are telling me about the mathematics of what they were doing, what they were looking for that they never got to. Okay? So the difference between energy, momentum, mass, and force is the speed of light squared, and that happens in dimensional shifts in phase transitions of time, where time gets frozen into a standing wave, and that standing wave becomes a single moment in time that propagates outward as a wave with these locked-in characteristics. And that's what the math is showing when you go down deeper and deeper where we started, where it all starts with the speed of light, and it gets knocked down into 1 kilogram of mass, then 1 kilogram of momentum, until it goes all the way to a frequency of the speed of light, and then just to 1 meter of light where I started. This is where I started, was 1 meter. And I got all the way to that point where light standing wave is basically a superposition of these characteristics of energy, momentum, mass, and force. Where mass inherits this moment, where during the phase transition of energy into mass, it has to give this little bit of momentum. It has to give this momentum in order to do that. And there was a little bit of momentum that was left over during the energy to mass time transition shift. And that little bit of energy that was left over from momentum in mass got turned into what we call gravity. This much right here. And you know how I figured this number out? Because this is the time period. If we use this as a wave, this is the superposition time period for mass at the speed of light, I believe. Yeah, see, look, frequency is the speed of light squared. And see, look, mass is Planck's constant. So when the smallest possible piece of mass possible, energy, the smallest amount of energy, which is Planck's constant, turns into the smallest amount of mass, Planck's constant as a mass, you get a superpositioned wave of a frequency of the squared speed of light, and this superposition becomes gravity. This is a small wave that everything has superpositioned within them. Like everything is, you could say, emitting this frequency of light. And this frequency of light has these characteristics locked in within them. So look at force. Force is that other 22102 number. This is that 1986 number. See, I bet each one of these, energy, momentum, mass, and force, these are all superpositioned time waves. This is a standing time wave. 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 And if you take each one of them, like let's say we already did this one as a wave already. We saw what that one was. So now use this one as a standing wave that's frozen in time. We'll figure out what is superpositioned within that standing time wave. See? Energy almost equals 1. And momentum is that standing time wave that we had before. So momentum, so which one did I do? I took momentum and I swapped it with the wavelength, and the wavelength became momentum, and the momentum became wavelength. So I basically just swapped two with each other, and now everything did a characteristic, a shift. See, look, Planck's constant became the time period. So each one of these is a superpositioned standing wave of not only light, but of time. A superposition of time where all of these measurements, see the 22102, Planck's constant, this one, the 3335 number, yeah, see there's the one right there. There's this one right here. Right, this one right here is Boltzmann's constant. If you take this number, right, if you take 1 and you divide it by this number right here, you get Boltzmann's constant exactly. So this right here, this standing wave of our previous one, this is the standing wave for this one. Yeah, see, I'm going to have to map this out for, because I can see all of this in my head, but trying to explain where it all is and keep track of it is not easy to do. But anyway, when the time period becomes Planck's constant, then Boltzmann's constant shows up right here. If you take 1 and divide it by this number, because energy has become 1. When energy becomes 1, you take that energy and you divide it by the equivalent temperature and you get Boltzmann's constant. See, this is all, I'm mathematically showing that all of these constants and all of these numbers are fixed coordinates in a multi-dimensional, multi-time dimensional, standing wave locked system where they all lock to like 1 joule of energy, the speed of light for momentum, the speed of light for mass, the speed of light for force, the speed of light for frequency, the speed of light for all these quantities all have locked-in time superposition standing waves, where those waves become a locked-in characteristic of those variables. Like when mass equals 1 force, 1 kilogram of force, that becomes gravity. That's why every single particle has gravity, because all of us have a standing wave within us with that characteristic in it. All of these are very small, very high, very, very high frequency waves. And if they're all superpositioned into us with Planck's constant, because we took Planck's constant as a wave and we started spreading it out into its characteristics, and we started to get all these extra numbers. So that means all these extra numbers are all superpositioned into Planck's constant. And that means that all of these characteristics are all embedded into every single packet of energy in the cosmos. That's why every single packet of energy has gravity. That's why every single packet of energy has these variables at these specific numbers locked into them, because standing wave of Planck's constant equals those characteristics. I'll bring them up like this. You take Planck's constant and you use it as a standing wave of time and energy, superposition time and energy, and you get the speed of light for energy. You get momentum is 1 kilogram per second. And look, mass equals the 3335 number, the standing wave time period for what is it, 1 gram of mass, or something like that, as force. Yeah, so this is the standing wave for gravity. So anything that has a mass of this number right here has gravity. So this is where gravity starts. If a mass is lower than this amount right here, I'm guessing it probably won't have gravity. But that's a very small piece of mass, so I'm pretty sure everything has at least that much mass in it, and it has gravity. But anyway, I could go on and on and on and on about this and go deeper and deeper, but I'm going to stop here before this video becomes way too long to post online. But you can see I'm following things on what these mathematical relationships are, and it's quite interesting how deep the rabbit hole goes when you follow mathematically where these numbers go. So reminder, this is Boltzmann's constant. This is the temperature for it when you have an energy of 1 and a temperature of this large number. You take this large number and you take 1 and divide it by that number, you get Boltzmann's constant exactly. And the rest of the numbers should speak for themselves as constants. Like the 3335 number is gravity. This is gravitational constant right here. This is Planck's constant right here. The 102 number is another one. Where is it? Yeah, this one right here. This 22102. This is another constant number right here. And this is probably another constant right here, because I used that one to get the next one, and so on and so forth. So these all become very important locked-in numbers. They're not just constants, but they're locked-in coordinates of standing time dimensional waves of light and time. And characteristics of energy, momentum, mass, and force are all locked into those standing waves by the dimensional shift of the speed of light squared between them. Every time you hit the speed of light squared between these variables, they all perform a dimensional shift from this one to the next one. They all shift one place. So that's the dimensional shift of time as light propagates from one dimension to another. Pretty interesting stuff. I wonder if I'm ever going to get anybody to believe me, because the math checks out. With the mathematics that Einstein, Planck, they were all chasing this truth about what the mathematics says about reality, what the constants say about a reality, what these numbers actually mean. And what these numbers are standing wave, locked in, time-dimensional coordinates of wave characteristics of energy, momentum, mass, force, and gravity. That's the deep secret of reality. All right? So there you have it. Thank you for watching.